Hey everyone, welcome to Practically We Bring Learning Alive. Now this is the fourth session of your elementary chemistry series and today we are going to learn about the writing a chemical formula. How to write a chemical formula. Okay. So I hope you all have seen that our previous series video, that is first thing we have learned about metals and non-metals. Then next thing is about acid, bases and salt. Then chemical reaction and equation, and now today we are going to learn about how to write a chemical formula. Okay, this is very important thing because chemistry is all about writing a chemical reaction. Okay, when you write a chemical reaction you need to know about how to write a particular chemical formula. If you know that, then you try to balance it and then you will get a particular chemical reaction. Okay, so for this we have created one story for you so that you can learn and link the things, that how to remember how to write a particular chemical formula. Okay, so our story character is Kyra, and we have learnt about that Kyra first saw a copper, then she thought of why copper is used in making vessels and this wires. Then she got to know why copper is reacting with sour substances. Then how your copper is getting reacted, like your Statue of Liberty, which is of copper, it should be brown in color, why it is getting green coating over it. Okay, so now today we are going to learn the thing writing a chemical formula, and this we will relate one story, and the story says that Kyra saw one thermite reaction. Yesterday I told you about the thermite welding, okay, or thermite reaction. So this reaction is used to join the railway tracks. Okay, so here the aluminium reacts with the iron oxide to give you iron in the molten form, and that iron which is in the molten form is used to join the tracks. Okay, so this is called what? Thermite welding. So here what we got to know, that your aluminium react with iron oxide to form iron in the molten form plus your aluminium oxide. Correct? So here this aluminium reacting with iron oxide to form iron in the molten form, and this iron will help in the joining the railway tracks, and this is called as thermite welding. Here in thermite welding, this is not only for iron, this is for any other metal which is reacting with any metal oxide. So now she thought, why this iron is written as Fe2O3? Why not FeO3? Or why not FeO? Why not FeO3? Why it is written Al2O3? Why it is not AlO or Al2O? Why Al2O3 only? Why is it written here? So for this, she should learn how to write a chemical formula. So she is thinking, why aluminium has a chemical formula, aluminium oxide has a chemical formula of Al2O3. Why Fe2O3 for iron oxide? Why CuSO4 for copper sulfate? Where is the 2 here? Why it is not using as Cu2SO4? Why only CuSO4? So for this, first of all, we need to learn something. Okay, so how to write these chemical formula? Then her teachers tell this, for this you need to learn symbols and valency. If you know how to write a chemical formula, then first of all you need to know what is the symbol for that particular element and what will be the valency of that element. So first of all, learn about the symbols. So symbols you can learn. How you can learn? This is the periodic table. Okay, so in this periodic table you have seen that there are many elements. Correct? So in this periodic table, each element is represented by its symbol. Each element is represented by its symbol. So here the hydrogen is represented as capital H, lithium as Li. Remember, whenever you are writing any symbol, the first letter should be capital, the second letter should be small. So for lithium, the first letter is capital and the second one is small. For beryllium, first letter should be capital and second letter should be small. For magnesium, first letter capital, second letter is small. So writing any of the symbol, if you are writing any symbol, then the first letter should be capital and the second letter should be small. If you can see any of these element symbol, then you got to know the every first letter is capital and second letter is small. This is one thing. Okay. Now for this, for every element or for every compound, you should know the symbol. For I said as earlier, hydrogen has a symbol capital H, lithium has a symbol Li, beryllium Be, boron for capital B, carbon capital C, nitrogen capital N, oxygen capital O, fluorine F, and neon capital N, small e. Okay, so this is the symbol. All in periodic table you find all the symbols of the element. Now the next thing is valency. I hope you learn about this symbol thing. Okay, remember, for writing any particular symbol, if you are writing, let's say magnesium chloride, okay, magnesium chloride. So for magnesium chloride, M should be capital and G should be small. For chloride, C should be capital and L should be small. This is what MgCl. For magnesium chloride, it is 2. Where does this 2 come from? I'll tell you, but later on. Now let us learn the valency. Now what is valency? If I want to define valency, then it is a combining capacity. Now what is this combining capacity? So first of all, valency is what? The number of valence electrons which are used to share or to gain to form a particular compound. Okay, number of valence electrons which are used to form a particular compound. For let's say for hydrogen, okay, if I am forming H2, then it means there is a hydrogen. There are how many hydrogen? 2 hydrogen. Each hydrogen has only 1 electron, correct? Each hydrogen has only 1 electron. Now they will share their 1 electron. They will share their 1 electron and form a single covalent bond. So here you can see this hydrogen have only 1 valence electron. If it shared this electron with this hydrogen, then it will have 2 valence electron and its duplet is completed. Then that means H2 is formed and this is the valency of hydrogen. That means it gives its 1 electron to become stable. So valency is what? Simple thing. Valency is what? If it is giving or it is sharing electron to become stable, that is its valency. For example, if you are still confused, I will give one more example. So this is the example of sodium chloride. Okay. Now see, here sodium and chlorine. Okay, sodium chloride. So sodium and chlorine. So sodium has 11 electron. Okay, 11 electron. So in the first shell 2 electrons are there. I'll write here. Okay, with different pens so that it is clear. Sodium, and there are 2 electrons in the first shell. Then 8 electrons in the second shell. How many? 4, 8. Then 1 electron in the outermost shell. Just don't go on the drawing part, okay? So this is chlorine. Okay. For chlorine, the atomic number is 17. That means 2 in the first shell. 8, 1, 2, 3, 4, 5, 6, 7, 8. And 7 in the 1, 2, 3, 4, 5, 6 and 1, 7. So here, if you see this, sodium has 1 valence electron, chlorine has 7 valence electron. Now if this sodium give its 1 electron, okay, it will become stable, because for stability it require 8 electron in the outermost shell. It should have completed their octet. Similarly for chlorine, if it gain this 1 electron, then it will have how many electrons in the outermost shell? 8. So the electronic configuration for sodium is 2, 8, 1 and for chlorine is 2, 8, 7. So there is one valence electron. Here are 7 valence electron. If this sodium will give this one electron to this chlorine, then it will become 2, 8 and it will become 2, 8, 8 because it gains this one electron. So here sodium is giving one electron to become stable. Chlorine is gaining one electron to become stable. So what is that? This valency of sodium is 1. Because it is giving that one electron to become stable. Here the chlorine is taking one electron to become stable. So here the valency of chlorine is 1. So what we got to know from here, that sodium has a valency 1 and chlorine has a valency 1. So what does that mean? What is valency? Valency is the combining capacity, or you can say the number of valence electron it will gain or share to become stable. That is the valency. So this is it is determined by the number of valence electron. So similarly for hydrogen, there is one valence electron. Okay, it requires one more electron to become stable. So the valency of hydrogen is 1. Similarly for sodium and chlorine, the valency is 1, 1 because it requires one electron to donate to so that it will become stable, and chlorine requires one electron to become stable. Okay, so this is what NaCl. So here if you see that sodium gave its one electron to chlorine and chlorine take this one electron. So sodium will become sodium positive because it is donating. Chlorine will become chlorine negative because it is taking. So positive and negative, it will form what? Ionic bond. It will form ionic bond because there is one positive, one negative. Why it is called as ionic bond? Because ions are formed here. Okay, whenever there is a donation of electron, or it will give the electron, giving of electron, then it will gain positive charge. Whenever they take the electron, okay, gaining of electron is what? It will get negatively charged. This is called anion and this is called cation. Cation and anion. So sodium forms sodium positive because it is forming what? It is giving one electron. And chlorine will become chlorine negative because it is gaining one electron. So positive, negative, they will attract each other and form what? Ionic bond. That's why its name is ionic. What do you mean by ionic? Ionic means where ions are formed and due to this ions they form a bond. So this is what we call ionic bond. So what we got to know from here, what is valency? The combining capacity of any element to become stable. So here if I talk about any other element, like for I told you magnesium chloride. Okay, so here magnesium and chlorine. So again chlorine has how many electron? 7 valence electron in the outermost shell. I'll draw only 7 valence electron. Okay, 1, 2, 3, 4, 5, 6, 7. For magnesium, what is the atomic number of magnesium? It is 12. So 2 in the outermost shell. So here magnesium has how many electrons? 2. Chlorine has 7. So this magnesium can give its 1 electron to chlorine. Now this chlorine will become stable. But what about this electron? It will require another chlorine for it. Okay, it will require another chlorine for it. 1, 2, 3, 4, 5, 6, 7. Okay, so it will require another chlorine for it, and this electron was given to this chlorine. So this magnesium give 1 electron to this chlorine and 1 electron to another chlorine. So here magnesium has a valency of 2 because it is donating 2 electron, and chlorine has a valency of gaining 1 electron, so chlorine becomes 1. So the valency of chlorine is 1 and magnesium is 2. Here the magnesium gives 1 electron to chlorine and now the chlorine has become stable, and this magnesium has given to this chlorine and now the chlorine is also stable. Now the magnesium and both the chlorines are stable. So this is the valency of magnesium and chlorine. Can you tell me what is the valency of your noble gases? You know what is noble gases? So I told you in the first class, metals and non-metals class, the 18th group element, all these elements, okay, in this 18th group, they are what? They are termed as noble gases. Why they are termed as noble gases? Because they are already stable. They are non-reactive. They won't react with any other element. So why they are not reacting? Because they are stable. So the valency of these noble gases is always 0. Why 0? Let us see. So here, if I talk about helium, okay, helium has atomic number 2. So it will have how many electrons in the first shell? 2 electrons. And we know that in the first shell, how many maximum electrons that can accommodate? There can be 2 electrons only. So that's why helium has 2 electrons. It is stable. What about another neon? Neon has atomic number 10. So here, neon, in the first shell, 2 electrons. In the next shell, it is having 8 electrons. So it is again stable. So neon is having 8 electrons in the outermost shell. So it is stable. Helium has 2 electrons, stable. It is having 8 electrons, stable. That means there is no requirement to give or to take electron to become stable, because they are already stable. If they are already stable, then why there is a need to give and take electron? So they are stable. That's why the valency of these elements is 0. Only hydrogen and helium are the 2 elements which form duplet. Okay, which form duplet. What do you mean by duplet? Duplet means 2 electrons in the outermost shell. If there are 2 electrons in the outermost shell, they complete their duplet. If there are 8 electrons in the outermost shell, then it is said to be completed as octet. Octet is what? 8 electron. Duplet means 2 electron. Only hydrogen and helium will form this duplet, and rest of the other element will form what? Octet. Okay. Now, the thing is, we got to know about symbols. We got to know about what? Valency. Now, how to write a chemical formula? Let us take the example of your copper sulfate. Now, this copper and this sulfate. Here the valency of copper is 2 and sulfate valency is 2. Now what we need to do? First of all, you need to write the element name. So element is copper and this is polyatomic ion, that is sulfate. Here the valency of copper is 2, sulfate is 2. Just cross multiply it. You will get Cu2SO4 whole twice. Now this 2 will be cancelled and it will be formed CuSO4. This is the chemical formula for your copper sulfate. What about magnesium chloride? Why it is MgCl2? For magnesium and chlorine, the valency of magnesium is what? 2. Chlorine is 1. Cross multiply it. You will get MgCl2. Okay. What about another thing? Let's say your sodium chloride, NaCl. So sodium has valency 1. Chlorine has valency 1. Cross multiply it, it will get NaCl. Okay. For hydrogen and oxygen, that is water, H2O. Why it is forming only H2O? Hydrogen and oxygen. Hydrogen has a valency 1. Oxygen has valency 2. Cross multiply it, you will get H2O. That is water. So this is how you will write a chemical formula. For writing a particular chemical formula, you should know the symbols. How to write the symbols of that particular element. Then after writing the symbols, then you will write the valency. Then cross multiply it. When you cross multiply it, you will get the chemical formula. Okay. Now, write down the chemical formula for ferrous oxide. For ferrous oxide, that is Fe2O3. How will I write Fe2O3? For iron and your oxide is oxygen. So oxygen valency is 2. Iron valency is 2. Here it is written as ferrous. Ferrous, OUS denotes the valency 2 of iron. Okay, there are more valencies like 3, that is called ferric. Okay, if the valency is 3, then it is called ferric. Here it is written ferrous oxide, that means the valency is 2. Now cross multiply it, you get Fe2O2, that means FeO. Okay, so not 3, it is ferric oxide. This is ferric oxide. Okay, this is ferric oxide. Here ferric oxide, iron and oxygen valency is 2, iron valency 3, just multiply it, just cross multiply it, you will get Fe2O3, ferric oxide. Okay, so ferric oxide is Fe2O3 and ferrous oxide is FeO. For aluminium oxide, Al and O, aluminium valency is 3, oxygen valency is 2, cross multiply it, you will get Al2O3. This is aluminium oxide. Okay, for zinc oxide, 2 valency, cross multiply it, you will get Zn2O2, that means ZnO. Okay, next is what? Magnesium chloride. I already told you how to write magnesium chloride. Mg and Cl, magnesium valency 2, chlorine valency 1. Cross multiply it, you will get MgCl2. Next is what? Copper carbonate. Copper and carbonate. Copper valency 2, carbonate valency 2. Cross multiply it, you get Cu2CO3 whole twice, that means CuCO3, copper carbonate. Okay, so this is how you need to write the chemical formula for these elements. So now I think you and Kyra both have learned that how to write a chemical formula. For writing a chemical formula, you should know 2 things, that is your symbols, name, how to write that particular symbol, and what will be the valency of that symbol. Then crisscross it and you will get your chemical formula or your chemical compound name. Okay, now we have completed this thing to how to write a particular chemical formula. Tomorrow we will be going, not tomorrow, next Monday we are going to discuss about element, compounds and mixture, and atomic. On Tuesday we will be going to discuss about atomic structure. So we have completed all these things. If you haven't seen this metal and non-metal, acid, basis and salt, and chemical reaction and equation, just go down there. There is a playlist called elementary chemistry. Click on it. You will get all the materials there. Okay. I hope you enjoyed the session. You have learned a lot today. So thank you. We will meet soon. Till then, bye-bye.